Okay, welcome everyone to workshop 2 of this series. The idea of this workshop series is to introduce everyone to Bubble Protocol from a developer's perspective. There will be 4 workshops in total. This is the second, and the aim of these workshops is to build this decentralized file vault app. And along the way, we'll learn how to use Bubble Protocol. And the app should look something like this. Hopefully, when we're finished, we'll be able to upload files and share them with our friends. We could possibly message our friends, and it'll be end-to-end encrypted. So in workshop 1, just to take you back, we did a quick overview of the protocol itself, what a bubble is. We had a look at access control contracts, the contracts that control access to the off-chain bubble. And we played around with the Bubble Tools command line tool to deploy our off-chain bubble and read and write files and so on. This second workshop is about the client SDK. So this is a JavaScript SDK, and it's there are 3 main classes that we'll be using. There's the bubble class, a content manager, and a deployable bubble class. And we're going to go over these classes in 2 parts. So the first part, we'll do a JavaScript demo of the bubble class and content manager. And in the second part, we'll actually build our app, and we will be deploying on-chain and off-chain parts of the bubble and using them within a React app. So a quick reminder of the Bubble ecosystem. So our protocol here, it interfaces with EVM-based blockchains. It's EVM compatible, so it's blockchain agnostic, and it is storage layer agnostic as well. So bubbles can be stored on home servers, cloud servers, company servers, or decentralized storage systems. In the first workshop, we used Bubble Tools on the left to interface with our protocol. In this workshop, we're going to be using the client SDK. So the 2 parts. Let's do a quick reminder before we begin of the what a bubble is. So there are 2 parts, an on-chain half and an off-chain half. The on-chain half protects the contents of the off-chain bubble by providing access permissions for each piece of data, with each file and directory within that bubble. So let's get cracking on with part A. So again, in workshop 1, these are the tools that we used. So we used Remix to deploy our contract to the Polygon blockchain. And we used Bubble Tools command line to play around with the off-chain bubble. And we stored our bubble on the Bubble private cloud, which is a cloud-based bubble server. In this workshop, or this part A, we will do pretty much the same, but instead of Bubble Tools, we'll write a JavaScript application, just a command line driven JavaScript application that uses the Bubble SDK, and that will allow us to go over the bubble class and the content manager. So let's get started. So here we have, this is VS Code. We're going to use, we've got part 1. These files, this workshop directory is on GitHub. The link can be found on the Discord server. So we have what we did in part 1 here, which was creating this smart contract. And so let's look at 2A. So the first thing we need to do is deploy our contract to the blockchain, just like we did before. So let's go to Remix. Here is our contract. And let's deploy it to the Polygon blockchain. So we'll use MetaMask to do that. Let it connect. It's not connecting. Let's refresh this. Connect to our local host so we get the file. Let it compile. And then let's reconnect. That looks a bit better. There we go. Right. So to deploy the contract, we need a login address. So for this, we're going to use Alice's logging account. If you remember from the first workshop, we had Alice and Bob, each with their own private keys. So we will, let's get a terminal window open. Sorry, I'm in the wrong window here. There we go. So let's get Alice's address. That's her login address. Copy that. We'll use her address as the login address. Wait for it to be mined. And there we go. So let's now create our file, a JavaScript file. Let's call it shared.js. It's going to make it a module, MJS. Okay, so what we're going to do is we'll go to GitHub and we'll look at the documentation. So in the developers menu, we can go to GitHub. We'll go to Bubble SDK. And because we're building an application, we'll look at the client library within the SDK. Now the help in the SDK has a quick start section. So let's go down to the bubble class. And let's create a bubble using this as a template. Obviously we're going to be importing here Bubble Protocol client, core, and crypto. So we're going to have to import those. So we need to first initialize a node package manager. Let's give it the default options. And we need to install the client, the core, crypto libraries. While that's installing, let's set our configuration here. So the chain we're using is the Polygon chain. That is chain ID 137. The contract, well, we need to get the address from the contract we just deployed. Let's go back to Remix. Copy that contract address. Paste it in there. And the provider we're going to be using is the Bubble Private Cloud. So if we go to the Bubble Private Cloud's website, which is vault.bubbleprotocol.com, down here, it lists the different endpoints that we have to support various chains. So here's the Polygon chain. Now if we copy that endpoint, then we can paste that in here. So this is our bubble ID. That uniquely identifies this bubble in the world. Now we need to get a private key here. So what we're going to do, we want to use Alice's key because Alice is the owner. So we're going to import it directly from the Bubble Tools location. So key, we'll import it using FS. FS as well. File sync. So we've got os.homedir and we've got /bubble tools wallet. So that should import the private key directly from Bubble Tools. And then we're going to use, we're going to create a key object, which is part of the ECDSA package. So, okay. So now here we can use key dot sign function to provide our sign function. So there we are. That's our initial setup. Now we're going to need the structure of the bubble. So we need these down here. And let's convert it to JavaScript. To type. Can keep doing that. Accept. Okay. Actually, we don't need bubble. Okay, there's our bubble structure. And then let's create our main script. Put it inside the try catch block. And bubble errors have a code and a message. So we can do, if it has an error code, then we can output that. Message error. Okay, so let's begin. So the first thing we need to do is create our off-chain bubble. So let's just output to our log, creating bubble. do that by calling the create function within the bubble class. That's it. And while we're there, let's list the root, the root directory. It's bubble.list content.root, which comes from here. Files. Okay, so we should be able to run this, and it should create the bubble and list the files within the root. So if we go node .mjs, let's see where we are. Such file or directory. Missed out the S. Let's try that again. To file ID, we need to bring that in from client. And content.root. Where are we? Let's see. Don't always rely on Copilot. 1, 2, 3. So there we are. We created the bubble and we listed the root directory. And then, of course, we can do all sorts of other things, like we can create a directory. So, yeah, content shared file directory. And we can list that directory. Shared file. There we go. And we can write a file. We use to file ID. That converts, as we saw up here, it converts, in this case, a number to a full 32 byte file ID. We can also give it a directory part and a file part. And if we list the directory again, we should see that new file appear. Let's just run this. Should fail because the bubble already exists. So we're creating a bubble that already exists. Now what we can do is we can use the silent option. And that will not generate an error if the bubble already exists. So there we go. We created the bubble, listed the root directory, created the shared file directory, listed it, wrote a file to it, listed the directory again, and that's the listing that we received. Now, again, if we add an option to this list here, we can add, for example, the long option adds more information to the file. The directory already exists. So we need the silent equals true again. And so we get the length, the create time, and the modified time for that file. Similarly, we can read we can append, we can delete. Let's delete. Again. And that. Let's change this. Instead of writing hello world, we will write hello. We will then read it back. Log contents. And then let's append. We're going to append world. And then we'll read it back. Let's see that we have it. Here. Contents already been declared. So we appended world to the file, and when we read the file back, you can see it appended it to the end of the file. We then deleted it, and we can see that the file is no longer in the shared directory. So let's have just a quick look at Content Manager. So this is the Bubble class. The Bubble class is used for complete management of your off-chain bubble, from creating the bubble, accessing it, and deleting the bubble. The Content Manager is really about it's a different way to access a bubble. So let's, instead of reading the second time here, instead of using Bubble to read it, let's use the Content Manager. So we'll use content manager.read. Let's just have a look at the parameters while we're here. So it needs a content ID, any options, and it needs a sign function if we're reading a private file. Now we are reading a private file. So in this case, we will give it, we need the content ID of the actual file that we're reading. Now there are different ways that we can get that content ID. One way, for example, is it's actually returned whenever you write to a file or append to a file. So we could say, we could do that, and then we can read F1 content ID. And yes, we need the sign function, which we can get from the key. Let's try that. So there, we use the content manager to read the file back. We can also, there is also the public content manager, which is used to read public files. So for example, if we go to Discord, in the RESTful API channel, You can use this URL here to read public content. So, for example, that's read hello world. There's not the hello world that we wrote. It's a different one. It's from a public bubble. If I copy that content ID, which is this long, complicated gibberish there, and then I can use the public content manager to read that. Public content manager. Read. New content ID, and then we'll post that long number. That should read that. Oh, didn't have it. There we go. So there we are. That's an example of the bubble class and the content manager. So that pretty much sums up part A. If anyone has any questions, please drop them in the chat or just jump on voice. So now on to part B. So part B is where we're going to create this app. So let's just take a step back and think about what we're actually doing here. So in Web 2, if we wanted to build this Vault app, we would need to create a backend server for the app. We would need to run that server. We would need to have authentication with our app, password and username login. And we need to maintain that server. Plus that server, of course, is a central repository of all our users' data. In Web 3, we are changing that architecture. So we no longer need a backend server because the backend is provided by decentralized infrastructure. So that's blockchains, it's off-chain storage systems like Bubble. And so Web 2 services become effectively just an app. And this ought to be the case. Within perhaps 5-10 years, we ought to be in the case where all current services, so think, Twitter and Facebook and Instagram, TikTok, all these things ought to be just apps running on top of decentralized infrastructure with no backend servers running. If we can scale Web3 sufficiently nowadays. So these are the tools we're going to be using today in part B. We're building a Reactor app. We're interfacing with the MetaMask wallet to provide access to the Polygon blockchain. We're using the Rainbow Kit user interface, which interfaces and allows you to connect to MetaMask and displays your account in a nice way and provides little pop-up windows and so on. And we're going to use WAGMI, which is more of our sort of back end of our app, to communicate with MetaMask to do things like deploy contracts and interface with contracts. And finally, we're going to use the Bubble SDK to interface with our off-chain storage provider, which is the Bubble Private Cloud. So this is kind of what we want the app to look like. We need some sort of home page that allows you to log in. Once you're logged in, you should go to your dashboard, which will list all the vaults that you're a part of. It should allow you to create a new vault, allow you to join a vault that you've been added as a member of. And clicking on one of those vaults ought to take us and show us the files in the vault and allow us to add new files, delete files, add members, remove members, and delete the vault. And so we want some sort of screen that allows us to add and remove members here. So this is kind of the thing we're going to build today. Now we're not going to build it entirely from scratch because that would take way too long. So what we can use is if we go back to GitHub. Let's get rid of some of these windows while we're here. If we go back to GitHub, we can go to the Bubble Protocol repository. In here, there's this dApp template. Now this is a template for a decentralized application. So it simply provides login sessions. It allows you to log in with your wallet, and it allows you to optionally use Wallet Connect to interface with remote wallets. No, WAGMI is actually used by RainbowKit. So RainbowKit is a user interface that's built on top of WAGMI. And in fact, WAGMI is built on another tool called VM. So that they're each sort of wrapping the lower layer to make it more user friendly. Right, so we're going to use this template here. So what we need to do is clone this repository and run an npm install. So let's clone this repository. Let's go into the 2b app directory. Get rid of that. And we'll clone it right into that directory. I'll just remove the link to GitHub in case I accidentally commit. And then we need to npm install. So while that's doing that, let's have a quick look at what this app looks like. This is the architecture of the app. Kind of a class and component architecture. So in the middle here, in the source directory, we have our entry point. On the left, we have our user interface. And these consist of pages and components, images, other files. And the user interface uses RainbowKit, as we discussed before. On the right, we have our model. Now, the model is where all the interesting stuff happens. And part of the model is we have a wallet class. That wallet encapsulates all the interactions with our wallet, allowing us to deploy contracts, for example. And that uses WAGMI. And then each time the user logs in with a wallet, when they select an account in their wallet, the app creates a session for that account. Now, if they change account in their wallet, it'll close the previous session and reopen a new session for that account. So a session represents like a login session, and it contains things like your login key, and it also contains any data that you want your session to retain between logins. So it actually stores data between logins in local storage in your browser. So what we're going to do today is we need to make some changes to this. So we're going to take the app, we're going to change the interface to add our Vault UI, and we're going to modify the session class to add our specific session data, like our set of vaults. And we're going to create this new Vault class. And this Vault class is what will interact which each instance of the Vault class will be a bubble. So let's go back to here. We've run npm install. We now need to configure our app. And there are 3 files that can be configured. We've got public index.html, source config, and this is an optional. If we want to use wallet connect, we need to do this third. We're not going to do that for now. We're going to just edit the public index.html and the source config. So let's go to here. So public index.html. This is where we have our title name that appears on the browser window. So what did we decide to call it? Was it safe share, wasn't it? Safe share. Yeah. Let's go to our config. So we need to give it a unique name, a bit like this. So we'll just call it safe share. And we need to give it more of a user readable name, safe share. And there we go. So now we should be able to do an npm start. I'm going to make sure it uses web browser. So once it's built the application, which will take 30 seconds maybe, we should hopefully see our skeleton app. So there it is. So this is the app as it comes straight out of GitHub from this dApp template project here. So let's just quickly explore this login process. So let's connect a wallet. We use MetaMask. This account. There we go. And now we can log in. And login will ask us to sign a specific login message. So by signing this login message, we are creating a unique login key, which anytime we log in using that wallet, we will get the same key. It's deterministic. And here is the dashboard in this dApp template. It just gives some information about the about the login session. So that's the chain that we're logged in with, the wallet account. There's our wallet address, our login address that's generated from our login key, and that's the public key that goes with our login key. Now, if I refresh this browser window, it will ask us to log in again. If I click Remember Me and log in, again, it asks to sign the same message. It will give us the same address and public key. And now if we refresh, we should automatically go straight to our dashboard. Okay, so that's the skeleton app. So now we need to think about modifying it. So let's just open this. I'll just commit that. So now we need to get on with these changes here. So the first thing we'll do is we will update the UI. Now, this isn't a workshop to explain how to do React user interfaces, so I have pre-prepared the user interface, and I will copy it straight in. Let's see. So inside the user interface directory, there's the app class. Inside the pages, we have our home page and our dashboard. And in our dashboard, we have various different components that implement what we need them to do. Now to use this won't compile straight out of the box. In fact, let's move this. Let's move this across to here so we can see what's happening as we. Hopefully you'll be able to see that. Now it won't compile immediately, but we only have to make a few modifications to our model to make it compile. So we're going to this session class. We need to provide the data that the user interface needs. In this case, what we need is our vault. So in our session class, I'll go back to here. This essentially is the view of our session, our logged in session. So we want to be listing our vaults, and we want to be providing functions to create a new vault, to join a vault, and various things like that. So let's add a vaults object, and we need to provide that vault object here in the session data. Stick on type. There we go. So now there we go. We now have this vaults page. Of course, if we try and create a vault, it's going to fail because we need to add some functions. So let's add our vault functions. So we're going to need create vault with a user's a name. Let's just put in placeholders for now. We'll do the same thing for our other functions that we need. We will have a load vault. So a vault parameter, we are going to need a join vault. Take vault ID. We will need a leave vault. We actually will call it forget vault. What else do we need? I think we'll need a delete vault as well. Okay. So now if we try and create a vault here, oh, one thing, we need to expose these to the user interface, which we do in here. So there, now we get a nicer reaction. Okay. Now let's add our Vault class. Let's do we'll just do a sort of a dummy version of this class for now. Let's think about what we need. So in our Vault, we're going to have a name. We're going to have a set of files. We're going to have a set of members. And we also need to know whether we have permissions to delete the Vault or not. So let's add these things. So we're going to have a name. We're going to have files, members. We'll have an isAdmin flag. And let's see, what else do we need? That should do it. We need to provide the name in our constructor. We will have an initialize operation, which will be an asynchronous operation. We'll need that later. And we need to provide this data to the user interface, which we will do via this state manager. So this, in the architecture here, all communication that goes between the user interface and the model goes through this state manager. This is like a very simplified version of React Redux. So the model can send events, so that data updates, to have the UI render them. And the UI can call and generate actions on the model. So we need a set of UI methods. Let's create a function. Zoom's playing with me. Let's get state data for UI, let's call it that. And so the UI, we need to provide this information here, the name, the files, the members, the admin, but we also need some state data that the user interface needs. So we're going to use a construction state, which we're going to set temporarily to constructed. We'll need an init state. State should be initialized. And that's, I think, all we need. And let's add a dispatch function. Dispatch UI. Dispatch UI. So we'll use the state manager, which we need to import. There. JS. Right, so we need to dispatch this data to the UI. Now we need to, because they're going to be multiple Vault objects, we need to create a unique ID for each object. So let's create a UUID. And let's try just anything really. Not now. Let's map.random, something like that. So that should do it. And we'll need to register with the state manager. That's it. Now we should export this class. And so let's just create a couple of dummy versions of this vault here. My vault. And let's see what happens. We now have my vault and shared vault. Now, of course, we haven't implemented this load vault yet. So load vault, it just needs to initialize the vault class. So we can do that. There we go. We have no files. There we have it. Let's add a couple of dummy files in there. One. Two. Let's add a couple of dummy members in there. Okay. Let's just take console. So read it and define. So we need to provide the vault functions we need. Let's put those in here. So the vault functions that we need need to be able to read a file. That for now. Write file. You should delete a file. We need to add a member. In fact, we're going to be using the if you remember our smart contract, we had a set members option where we add an array of addresses and we set it to either true or false. So we'll have an add members and we'll provide the public keys for those members, which will be useful when we come to encrypt the bubble. And remove members, in this case, that would be addresses. And we need a function to delete the vault. So there we have. We click on there, we get an error. Read file not implemented. Click on delete, we get an error. Members, some members. And we can forget vault, and that's not implemented yet. So let's implement a few of those things that we can with this data here. So in our session, we can do things like we can add forget vault. We just need to filter our local vault object, and let's see. We need to save the state. We'll need to dispatch dispatch the UI. Let's add a dispatch section. Dispatch to dispatch UI data. And we can do the same thing with delete vault. We already have a vault delete function within our vault. So we can just do that, and then we can actually just forget vault. Yeah. We've already got load vault. And let's add create vault. Okay, that should do it. Let's create a new vault test as our default skeleton values in there. Let's forget them all. Okay, so that's effectively gives us a skeleton vault app. Now we just need to add the actual bubble functionality. So let's just check this in first. Okay, so now we need to convert this to a bubble. If we go to our go to the Bubble SDK help, client library. Now in here we have the deployable bubble class. Now each of our vaults, each of the user's vaults is going to be its own bubble. And of course, to create a bubble, we have to deploy the bubble smart contract. We have to create the off-chain bubble. We've got to set up any contents within the off-chain bubble, like the metadata, create any directories we want. And so anything can go wrong in that process. So for example, if the contract was deployed successfully, but the off-chain bubble couldn't be deployed because the storage provider was down for some reason, let's say, then we're going to be left in a partially initialized state. And if we don't handle that properly, we'll end up losing our smart contract, which we paid money for. So we want to keep track of the initialization process so that we can retry it. And that's exactly what this deployable bubble class does. So it manages that bubble construction process, and it manages the initialization process every time in the future that you use that bubble. So to use a deployable bubble class, we need to provide it with the source code for the contract, well, not actually the source code, the bytecode and the ABI. We need to store the bubbles metadata between between user logins. So it needs to store the construction state and so on, which we'll do in local storage. And we need to provide it with a wallet object, which contains functions to deploy, send, and get chain ID. And finally, we need these set content constructor and set content initializer hooks if we want to create custom content in our bubble during construction. Then we pass a function to set content constructor. If we need to initialize certain content every time we open a bubble, then we need to pass a function to set content initializer. So there's an example here. This example extends the deployable bubble class. You don't have to, you can use it separately. But it means that the Vault inherits all the functions of that class. And you can see in its constructor that it's setting the content constructor, the content initializer, to these functions here. And those functions, for example, during construction, it writes the metadata file and it creates a file directory. So this is a pretty good example for us to copy. So let's just copy that into our Vault class. Let's pop it down here for now. And we're going to need those. We won't need those. And so let's copy this template. So we want to extend deployable bubble. Our constructor. Let's copy our constructor signature there. So in this case, we'll actually, rather than taking contract source code as a parameter, because we know what that source code is, we can import it directly into this file. So we will import contract source code, and we will create a new file. In a JSON file. There. Let's do that now. So create a new folder, contracts. Create a new file with our contract source code in. And in here, we look here, we can see we need ABI and bytecode. So where did we get the ABI and bytecode from? Well, if we go to our contract in Remix, in the compiler menu, we have ABI and bytecode, and we can copy those directly and paste them directly into here. And bytecode. So there we are. So that will allow the deployable bubble class to actually deploy a bubble for us on our behalf. Okay. Now we don't currently have these functions, construct bubble contents, initialize bubble contents. Let's copy those across. part of instruction. And we also need some way of passing the data out to our session, so the session can save our vault information. So let's create let's copy that function there, get metadata. So get metadata returns the metadata from the parent class, which will include things like the construction state, and the bubble ID. And we need to add our own anything else we want to save. Now, in this case, name is all we want to save because everything else we can read directly from the bubble or from the smart contract. So we just need to save the name, so we don't have to load all the bubbles on app initialization. Just to save confusion, let's call that get session metadata, because we've got a few different types of metadata here. Now, construct bubble contents. This is pretty much what we want to do. We need the contents of our bubble here. So we got that earlier in part A. So we have our bubble structure there. We can just copy that straight across. Pop it up here. Content, metadata file, and shared file directory. And okay, we want to do something a bit more interesting with this. So let's put it in a separate, let's write our metadata in a separate function. Let's call it vault metadata. Let's create some internal functions down here. Vault metadata. Let's work out what our metadata should be. So we need to store this is the metadata that will be written inside our vault, so that if somebody else joins our vault, they can read this information for themselves. So we're going to store the name, we're going to store the members, but we don't need to store the files or the admin status because those can be read directly from the bubble. So we'll write that. Okay. Yep, that should do. Now in our initialization process, so we've done the construction process. In the initialization process, we need to read our metadata file, and we need to read our files or the list of files from the bubble. So again, let's create separate routines for that. Let's read vault metadata. Read vault files. Right, there we go. Read vault metadata. Let's see how Copilot does here. So it's reading the JSON straight from our bubble. It's parsing it into metadata, it's setting name and members. So that looks pretty good. Let's read the files. List.files, bubble.list, shared file directory. We want to we want to read all the extra information for it. So that should do. There we go. So now the initialization process. Let's see, do we have initialization in here? No. Okay, initialization process. We need to call our parent initialization routine. And we need to pass, that requires the contract parameters. That's the contract constructor parameters. So if you remember our contract in the constructor, we have to pass the login address. So we need to bring that in here, login address, and we'll pass that as an array. It's an array of parameters. And we need to await that. And we want to store this login address for later. Let's stop login address. Now, if in the initialization process the contract is deployed, then we want to call the contract and call the isAdmin function to find out whether we are an administrator or not. But we only want to do that if the contract is deployed. So the deployable Bubble class has a bunch of getter functions. So here we can see we've got is Bubble deployed, is contract deployed, is it failed, is it initialized, and so on. So we can use is contract deployed to determine if it's deployed, and then if it is, we can await, and we'll create a function called get admin status. And finally, let's dispatch the UI data. So we need to add this new function here, admin status. We use that to set this.admin. Now we have a contract object as part of the deployable Bubble class. There's a contract object, and that we can call, send, or deploy a bubble. So we can call this isAdmin function, passing it our login address. So that means we'll be calling this function in our smart contract with our login address, and that should return true or false. Okay, let's just add some trace so that we can see what if anything goes wrong, we've got some information. Files. On Copilot, it's been a bit slow. All right. Well, let's see where we are then. So Vault line 27, unexpected use of name. So name comes from metadata. So we want metadata.name. And let's add an assertion so that we can Come on. We'll add an assertion so that it will raise a flag if there's a problem. So it's string. There we go. Get admin status. What did I say? Get admin status. This. Metadata. Oh, so we haven't changed how session is constructing these vault instances. So we're just passing it the name at the moment. So first of all, let's get rid of those. Second of all, let's in our create vault, when we create a vault, we need to add name as the metadata. And we needed our wallet, start wallet, and we need a sign function, which is the stop logging key sign function. So now we're using this bubble class. We need to slightly alter what we're doing here. So we need to test. We only want to save the vault if it's at least deployed the smart contract. So we can use vault.is contract deployed. And if it is, then we can do all this. We also need to check if the initialization has failed. Is failed. Or throw error. So that looks pretty good. Now, if we're going to store these vaults between login sessions, then we need to change what we're doing in these two functions here. So this function is called whenever the state data is saved. So we need to get all our vaults. We need to map. We just want to get the session data for each vault. So we'll just save that data. Similarly here, we want to, if there is a vault, there are vaults in the state data, and we need to create our vault classes for each saved vault. Now we've got a slight problem here because this login key may not exist at this point. That login key only exists once we've logged in, whereas the session exists even if we just selected an account in our wallet. So we can't pass login key there. So let's just create a dummy sign function. Make it a async function. Pass that there. But it means we need to set the sign function at initialization time, which is here. Now, we needed the login address. Login key.address. But we're also going to have to pass now this sign function as well, which means in the vault class, we need to handle that sign function. Just overwrite the deployable bubbles sign function there. That should work. Let's see. Now, once we've initialized, well, actually, if the vault is already initialized, we just want to return the vault. So if vault.is initialized, otherwise we wait for it to initialize. And of course, when it initializes, it might read some new information from the bubble, like new members or something like that, change name, something. So we need to save. We need to save the state. And let's see where we are. Let's try and create our first vault. Nothing happens. So it would help if we initialize the vault here. So we create a vault. We now need to initialize it. There we are. Let's try that again. Bubble provider not set. Right, so when we create a new bubble, we need to tell it which provider, which off-chain provider to use. Normally, it would get that from its metadata, from its bubble ID, but of course we haven't got a bubble ID yet. We haven't deployed a bubble. So we need to tell it what its what the bubble provider needs to be. So for now, just keep it simple. We'll hard code a bubble ID in our configuration data. Bubble ID, bubble provider. And we want to use the bubble private cloud, which again we got in part A, which was this. Yeah. Creating a new. Okay, let's go back to session here. So we need to set the bubble provider. There are a few ways we can do that. We can pass it in as an option, or we can call this function here. Right, let's try that then. The provider still not set. Why is that? Why is that then? No, put it in the wrong place. That's why. Need to put it before we call the initialize routine. Right, so deployable bubble is calling our wallet to deploy the contract. It's going to cost 3 cents. And there it is. There's our bubble. Let's open our bubble and see if that works. So far, so good. Can we look at members? Ah, we still have our default dummy data in our vault, of course. Let's get rid of that. Let's go to members. Of course, it saved them, hasn't it? Okay, let's oh, and it says that we are not the owner. Why is that? Is admin, have we passed it? Yeah. Did we got admin status? This .login address, that looks okay. That should say delete vault instead of forget vault if we're admin. Okay, let's look at that in a little while. Let's create a new vault first. It's 2 members. Now we've got no members. We should have a member. We should have our own login address as a member. So when we need to add that here. So when we construct the bubble contents, we need to actually set our initialize our members array. There we go. So we should get that next time we create a bubble. Let's see, did that say? Yeah, so still we need to sort that out. So why are we not seeing delete vault? Let's have a look at what we've logged here. Getting admin status. Let's debug that. Actually, we don't need this anymore. Debug admin. Contract.call is admin this login address. That looks okay to me. Let's see. So output true. So it could. Do we need to dispatch to the UI perhaps? No, it's still saying that. Why is that then? Is admin, this dot is admin. That's why. So I just set this dot admin. So is admin equals that. So let's try that then. That's better. Right, so we can now try and delete vault because we haven't implemented it yet. So let's let's start implementing a few of these vault functions now. So we want to read a file. So let's add a trace reading file name, let's say. Now, Bubble Protocol currently doesn't support MIME types. And we're going to need to store the MIME type with the file. So what we can do is we can add the MIME type to the file name when we save it. So I'm going to use, I've created a different class that will allow us to do that, which we'll put in our utils directory. So this file name with MIME type takes a name and a MIME type, and it appends them together with a URL style. One of those things. So we can use that in here when we save the file. So let's create a set of file name with type, construct file.name, file.type. That looks right. And then we need to write the read the file. This .bubble.read, and we need to use two file ID, the shared directory and the file name, and we want to return those contents. So that should do it. Similarly, write file. File name, construct, yeah. It's not bubbles, it's should just be this. Write. Contents. That looks pretty good. And then after we've written, and this would be writing a new file, let's read the files back from the directory. And that should refresh the user interface as well. Just check we have done that. Read vault files. We need to update the user interface here. Same thing when we read the vault metadata as well. Delete file, same sort of thing. Exactly, looks pretty good. Delete vault. We have a delete bubble function. We can just call that. So now to add members and remove members, we're actually calling the set members function in the contract. So we need to convert these public keys to addresses first. Yep, that's good. This.contract.send, and it is set members, and it is addresses, comma, true. And remove members is very similar. Now, of course, once we've added members, we need to, or added and removed members, we need to update our, we need to write the metadata. We need to write metadata. We'll call that, and that should update the UI as well. Is that right? Vault metadata. No, it doesn't, so we need to do that ourselves. And do the same thing here. So that's all the Vault functions implemented. Let's go and see how we've done. Let's add some files. Let's add a new text. Right, so we haven't quite handled the file naming here. So let's go to our read vault files. So we've just set files directly to what comes back from the vault, but we want to remove, we don't want this directory in there. So files.map. So we deconstruct the name, and we need to, first of all, we need to remove the directory. So we're going to use bubble file name, which is part of the core library. file name. Name. So now we can use b.name, so bname. And we can get the file part, convert it back to name and type. And then we need to pass all the rest of the data that's as part of this, the file, which is like the length and the created date and so on. And that should hopefully do it. There we go, hello text. So can we delete it? Yep. Let's add a new file. Can we download it? Yeah. Can we open it? Let's go to workshops. Workshops. Let's put it in there. Just replaced it. Let's open in a different window. Oh, there we go. So that seems to work. We can download it. We can add files. We can delete files. So a few others. Okay. Members. Let's see what we can do with members. Let's add. Now, well, let's see if we can share this with, let's say, Alice. So we need to get Alice's public key in order to add a member. So if I use Bubble Wallet info Alice, that gives me the Alice's address. If I add the -p option, that gives the public key as well. So if we copy the public key, before I do that, let's go to let's go to Alice and see if we can read the bubble. So we want bubble content. Let's list. And we want the bubble cloud. We want our contract address, which we can get. We can't get that yet. So we need to add in this state data for UI, we need to add the bubble ID. Bubble ID. We will also need a vault ID. Bubble ID to string. Or when we come to share the bubble. So let's go to test one, show vault details. It's still not there. It's because I misspelled it. Try it again. There we go. So there's the details of our vault. So if I copy that contract address and we go back to Alice, contract, we're going to read file 2, and list file 2, which is a shared file directory, as Alice with Polygon chain. Permission denied, as it ought to. So back to here, let's copy this public key and let's add Alice as a member and make sure that it works. Add. Yeah, of course it's a blockchain transaction. Wait for it to be mined. Interesting. Should display there. Let's see. Well, first of all, before we do that, let's just see. It should have given permission there. So there we go. Now Alice has permission to read those files. But why did it not update the user interface? Because we didn't change our members here, did we? So we need to members.push addresses. And we need to filter out any copies as well. I'll do it. And similarly, remove members. That's pretty good. All right. So let's go back here and add a member. Doesn't matter that we're adding the same member again. Hopefully it should update the UI and the metadata. There we go. Let's refresh, double check. Members, that's good. Let's remove member, make sure we can still access, yeah. Let's remove Alice as a member. Okay, let's see if make sure she's lost permission. Good, okay. Right, so that's adding and removing members. We can add new files, we can download them, we can delete them. Let's make sure we can delete the vault. Done. That's good. Right, finally, the last thing we need to do is add this join vault capability so that we can join somebody else's vault. So let's go to session. That's still to do. And let's so again, we need to create a new vault. Let's see, how's that done? Not quite right. Bubble ID, so bubble ID to vault ID, that should work. And we need to give it a name. It's just a dummy name for temporary name. Temp. And we need to set the constructed state because the bubble is already constructed. We don't want it trying to deploy a new contract. So construction state is constructed. This dot wallet, this dot sign function. Await initialize. If it's deployed. Well, we don't need that because we know it's already deployed. So return the vault. If it fails, we don't want to add it. So we want to move that here. So that should do. Hopefully that should do it. Right, so let's go over here. And let's, why did it do that? Why did it do that? Come on. Oh, oh yeah. Just want to set up two windows in two different browsers so that we can pretend to be two different people. Better. So we've got Chrome on the right and we've got Brave on the left. So let's create let's create a new vault. Let's call it shared. Okay, let's add a few files. And let's log in on here. Your vaults. So it says here to join a friend's vault, click plus and paste the vault ID. So we need to get the vault ID from here. Copy vault ID. Paste it in there. Permission denied. Of course, we haven't added this person as a member of the vault yet. So we need a member ID. So we'll copy his public ID, paste it in here. Let's copy the vault ID. Add it over here. And now we have shared vault with the files. Check the members. Great. Now in this case, of course, because we're not an admin, we can only forget, we can't delete. Even if we tried to delete, the smart contract wouldn't let us. Whereas on this side, we are an admin, so we can delete. Right, so that's pretty much, I think we're pretty much there. That's all the functions, I think, complete. Yeah, next time, of course, the vault that we've built today, the app that we built today deploys vaults, but the vaults themselves are unencrypted. So next time, in the next workshop, we'll add encryption so that the vault can be encrypted. And we will also add this auto refresh. So one thing you'll notice, let's go back here. One thing we'll notice, if we both go to shared vault, if we add a new file on here, of course, it doesn't automatically appear up here. We have to refresh. That's a bit of a pain. So next time we will add a auto refresh feature, which will use Bubble Protocol's real-time notification feature. So we'll demonstrate next time encryption and real-time notifications. And then, of course, if anyone wants to, they can take this app and start making improvements if they want to. Make a better user interface, for example. We may or may not add messaging to that app. We can demonstrate all Bubble Protocol features just with these two. cross-device support, of course, the app, if you log into using the same wallet but on a different device, you won't automatically get your list of vaults. So we need to add cross-device support. Now that can be done in a number of ways. It could be done on chain, storing the list of vaults that you're a member of on chain. Another way is we could have a dedicated application level bubble to hold the list of people's vaults. And so there we are. So I think we'll call that a day.